Hello kids, Shubhamangalam at Little Scholars. Myself Sukhdeep. I'll be taking up class 8th for today and I handle physics of course. And then we are going to move to the chapter 2, friction. We are on page number 19. I'll be teaching 19 and 20 right now. And yes, the further pages also. So yes class, we are in the next chapter. I hope you have read the first chapter and you have understood what is it about. What was the name of the first chapter? It was force. We studied about different kinds of forces like contact and the field forces. So amongst the contact forces, we have studied about the muscular force, the normal force, the frictional force. So here we are going to study about friction in a detailed uh, detailed way. So now, what was frictional force? What did you study from the last chapter? What was the example that we always discuss? If on a floor I'm going to roll a marble, it is going to roll to a certain distance and stop at a certain point. Now, why is the ball stopping at that particular point? What is making the ball to stop at that point? There is a limiting force. There is a resisting force which is stopping the ball from moving further. That is the reason the ball gradually decreases its speed and comes to rest at a certain point. What is this limiting or resisting force called as? Frictional force, or the force of friction. Fine. So now we are going to learn about something over here. Okay, identifying forces acting on a body and effect of frictional force. So basically, for example, there's a table placed and on the table I place a book. Okay, initially the book is at rest. So this means the force acting on the book is zero. The net force is zero. We studied this in the free body diagram last time. Okay, in the last chapter. Listen to me very carefully. If I place a table and if I place a book on it and there is no movement happening on the book, I am not pushing or I am not sliding the book, this means the book remains in its position. So the net force acting on the book remains zero. But I need to identify what forces acting on the book. So I push the book gently. Then the book moves in a certain direction, and after moving in a certain direction, it gradually decreases its speed and stops. Something like this. Okay, if this was the book, there would be four forces acting on the book. Okay, it is moving with a certain velocity in a certain direction, but after moving to a certain point, it stopped. It stopped because of which force? The frictional force, which is denoted by small f. So these two are the forces acting in the horizontal direction on the book. Now what forces are acting in the vertical direction? There are two forces again acting in the vertical direction. Because the book is placed on a table, it is supported by a solid surface, then there is a normal force acting on the book in a perpendicular direction, which is vertically upwards, which is nothing but the normal force. Which force is acting downwards? The weight of the book or the gravitational pull of the book. So you need to know there are four forces acting on the book. Okay, the force with which the book is moving, the force because of which the book stops moving, the weight of the book or the gravitational force of the book which is pulling it down, and the normal force which is acting vertically upwards. Okay with this one? These were the four forces. Now look at this, identifying forces acting on a body. We have done this part. And effect of frictional force. What was the effect of frictional force over here? It decreased the speed with which the book was moving. Okay, and it gradually came to rest because of frictional force. That was the effect of frictional force on a moving body. Okay, now does the book move with uniform speed? Do you think so? Is it moving with uniform speed? No, it is not. It decreases its speed and comes to a halt. Now, what are the forces acting on the book? How many forces? Four forces. I've mentioned it in a diagram over here. It is the velocity with which the book is moving. It is the frictional force because of which the book stops. The weight of the book or the gravitational pull pulling it downwards. And the normal force which is acting vertically upwards. Okay, now let's calculate the net force vertically. Okay, when I am pushing the book on the table, how is the book moving? Horizontally or vertically? It is moving horizontally. I am not lifting the book and taking it to a certain position. I am only sliding the book horizontally. So there is no movement happening vertically. This means the vertical forces. Which are the two vertical forces over here? The gravitational pull and the normal force. Both of them are equal to each other. That is why the net force vertically acting on the book is zero. Do you understand now? What were the two forces which were acting vertically? It was the weight of the book and the normal force. Both of them are equal and opposite in direction. So when you subtract them, when you find out the net force vertically, what do you get? 0, because they're equal and opposite. For example, this is 1 Newton minus 1 Newton. 1 minus 1 is going to give you how much? 0. You know that I am sliding the book on the table horizontally. I am not lifting it up. There is no movement happening in the vertical direction. That is why the net force vertically is 0. Now let's calculate the net force horizontally. What did we do? We slide the book in the certain direction and it moves to a certain point. Okay, after moving to a certain point, it stopped because of frictional force. This means here the force with which the book was moving was slightly dominant over the frictional force initially, but after moving to a certain point, the frictional force became more dominant to the velocity with which the book was moving. I'm repeating it again. Listen to me very carefully. The net force vertically here is 0 because the book is not moving up and down. Okay, it is moving on the side. It is moving horizontally. Now, this is 0 and I guess this is clear to you. We are going to calculate the net force horizontally. When I am pushing the book in a certain direction, initially, the force with which I am pushing the book, that is more dominant when compared to the frictional force. Okay, now after reaching a certain point, when the book comes to rest, the frictional force becomes more dominant when compared to the velocity with which the book was moving. Okay, we will understand the further concepts now. So now class, we'll continue with the chapter and this is page number 20 basically. So now we are going to understand the nature of friction and the concept of friction over here. Okay, we have a setup over here where there is a table and on the table I place a toy trolley with which we must have played when we were really young, and on the toy trolley I am placing a block, a wooden block basically. I'm shading the block so that you know what is the block over here. Okay, and now I am attaching it to a string with the help of a pulley and attaching a weight. Okay, I'll explain the setup again. We have a table over here and on the table I am placing the toy trolley. On the toy trolley there is a wooden block placed which is attached to a weight, a certain amount of weight with the help of a pulley and a string. Okay class, so now because there is a certain weight over here, what do you think is going to happen to the toy trolley? It is going to move a bit, yes or no? Because if there was no weight and I was just holding it, then it would stay in its own position. Fine, if I pull it, definitely it is going to move. So instead of doing the pulling and pushing over here myself or manually, what did I do? I attach a certain amount of weight. Okay, when I attach a certain amount of weight, there is a certain movement in the toy trolley's motion. Okay, in its position. As the toy trolley moves, the wooden block which is kept on the toy trolley also starts moving. Okay, but you need to keep a thing in your mind that the block is not going to fall initially because the weight that we are using here is very less initially. Okay, it is also going to move along with the trolley. You need to understand that the block is in rest with relative to the toy trolley over here. The toy trolley is in motion relative to the table. Okay, with everyone, it is the toy trolley moving on the table. It is not the block, but the block is placed on the toy trolley. The block is at a rest position with respect to the trolley. Okay, the block is at rest position with respect to the trolley, but the trolley is in motion with respect to the table. Remember this point for now. Now, if I keep increasing the weight, what is going to happen? Okay, it is going to move a little more faster. It is going to catch some acceleration, yes or no? So if I increase the weight over here, the toy trolley is going to move faster. If I keep increasing the weight, what is going to happen? The block which is kept on the toy trolley is going to fall down. It is going to fall down in the reverse direction. Now the force which enables the wooden block to fall in the reverse direction is nothing but the frictional force. Okay, it is not allowing the wooden block to move further because of the extensive weight placed on this end. Do you understand now? So here we are going to discuss two types of friction. The first being sliding friction. Okay, by the name itself you might be able to understand what is sliding on the table over here. What is sliding on the table? It is the trolley sliding on the table. Okay, the trolley is in motion with respect to the table and it is undergoing sliding friction. What is static friction? Static friction is observed in objects when they are kept at rest with respect to other objects. Which object is at rest with respect to another over here? It is the wooden block. So it is the wooden block which is going to experience static friction because it is at rest when compared with respect to the trolley which is already moving in sliding friction. So what are the two kinds of friction over here? Sliding and static friction. What is experiencing sliding friction? It is the trolley which is experiencing the sliding friction because I am increasing the weight over here. Once I increase it after a certain limit, till I reach a certain limit, the trolley is going to move to us with a certain speed which is going to enable the wooden block to fall down in the reverse direction, and that is nothing but because of the frictional force. But what was the friction experienced by the wooden block when it was placed on the trolley? So it is the static friction experienced by the wooden block when it is kept on the trolley because it is at rest with respect to the trolley. Okay, let's try to deal these questions over here. What happens to the position of the block moving on the trolley? Initially, when there is less weight, the trolley is going to move and the block is placed on it and the block is not falling down. But as I keep increasing the weight over here, it reaches a certain limit and the block falls down because of frictional force. Yes. What happens when we change the weight? The block falls down, okay, because it has reached to a limit point. Now, what happens if I apply grease to the bottom of the wooden block? Now, if I apply grease to the bottom of the wooden block and I keep increasing the weight over here, the block is definitely going to fall down in the first case itself because that is going to reduce the friction. Do you understand? All these smooth surfaces and lubricants are basically used so as to reduce the friction. Now, where will we? What are the two types of forces discussed over here? What are the two types of forces, class? It is the sliding friction and it is the static friction. What is experiencing the sliding friction on what? The trolley on the table. It is moving in a sliding way. That is why we call it as sliding friction. Now, static friction, it does not keep moving all the time. Okay, it is going to move and reach a certain point and stop. That's called as sliding friction. Next, we have a static friction. What is static friction over here? When the body is at rest with respect to any other object. Okay, what is the body which is at rest over here? It is the wooden block. Okay with everyone? And once the weight starts increasing and it falls in the reverse direction, that is all because of deceleration. Okay, and that deceleration happened because of frictional force. What do you mean by deceleration? Acceleration in the reverse direction. Okay with everyone? The wooden block is going to fall in the reverse direction. That is why that is called as deceleration, which happened because of frictional force. Okay. So class, we are done with page number 19, 20 and 21, which was very easy. It was just basically discussing about static and sliding friction with the help of an activity that I just told you. So we are on activity 2 right now, observing the variation of friction. What do you mean by variation of friction over here? Less or more? Varied. What do you mean by varied? At different levels. Okay. Basic dictionary meanings. So now, observing the variation of friction, and what is the example that I've written over here? Pushing a heavy box. Now listen to me very carefully. If there was a very heavy box in our class and I ask somebody to push it so that it changes its position, so that it is moved from one class to the other. If I tell one single boy to come up and push the box so that the box is placed in the second room, will he be able to push that heavy box alone? No, it is going to be slightly difficult for him initially when he's applying only less force. Okay, when he's applying, you need to understand. The first case is going to be he doesn't know what is there inside the box. So he's going to apply very less amount of force. If you apply less amount of force to a very heavy box, will you be able to push it to a certain position? No, it is very difficult. Now that he have understood, that the box is really heavy and he needs to increase the force that he needs to apply on the box over here, he is going to try the second time with more strength. So in case number 2, the boy is going to push the box with more amount of force and strength, and this time the box starts moving. Now, is the box rolling and going, or is it sliding and going, or is it being lifted up and taken along? No, you are pushing the box which is placed on the floor. This means the box is in contact with the floor. When the box is in contact with the floor and it is being pushed in a certain direction, the friction between the box and the floor is nothing but the sliding friction. So what do you conclude from this? That the box is experiencing sliding friction on the floor because of the force applied by the boy. Did you understand now? So that was what we were observing, the variation of friction over here. Earlier when less force was applied, there was more friction. This means we were not able to push the box at all. When more force is applied, we are able to dominate frictional force and we are able to push it to a certain position. And what is the friction that we are talking about? It is sliding friction. Okay, now the next part of the chapter, we are going to discuss about factors which are going to affect friction. Okay, there are factors affecting everything that happens in science. Even water cycle has certain factors. Similarly, friction here also has certain factors. I'll just read it out for you first and then we will deal with it one by one. Effect of roughness on frictional force, effect of area of contact on frictional force, and effect of the normal force on friction. Let's deal with the first one over here. Okay, if I build an inclined plane, fine, and on the inclined plane I'm going to roll a marble. Let me build an inclined plane with with a wooden surface. All of us know that wooden surfaces are pretty rough. Okay, I have built an inclined plane with the help of some wood. Fine, now what am I going to do? I am going to roll a marble on this. Okay with everyone? This is my case number 1. In case number 2, I am going to build the inclined plane and place a cloth on this. Okay, after placing the cloth, I am again going to roll a marble on this one. Fine, and I am going to observe in which case the marble is able to move faster. After observing both of these cases, in the third case, I am going to build an inclined plane with the help of glass. Okay, this inclined plane over here is made up of glass and I'm going to roll the marble on this. Okay, and this is my third case. Where do you think the marble is going to travel the fastest? In the third case. Why do you think so? Because it is comparatively smooth when compared to the wooden surface as well as the cloth surface. The cloth is also smooth, but it has folds, yes or no? It is going to be wrinkled at some of the other position when the marble is going to roll down. It is not going to be tightened. Do you understand? But the glass surface over here is smooth and doesn't have any rough surfaces, doesn't have any interlocking with the marble over here. So that is the reason the marble is easily able to move on the glass surface because of the smoothness of the surface. Okay, this means the glass marble over here is experiencing less friction. Do you understand? Now, this means the smooth surfaces are going to reduce friction. So what is going to increase friction then? Rough surfaces. So to increase friction, which kind of surfaces do we need to use? We need to use rough surfaces. Okay with everyone? You need to remember this, that the rough surfaces produce or increase friction, whereas the smooth surfaces reduce the friction. Okay with everyone? They are going to be very smooth and the ball is going to roll down very easily. But in our wooden surface case, it is going to be much slower when compared to the glass surface. Let's recollect what we have studied over here. Which was the factor we were studying? The first factor, effect of roughness on frictional force. Okay, first case, I am going to build an inclined plane with the help of some wood. In the second case, I am going to place a cloth. In the third case, I am going to use a glass surface to build the inclined plane. In all the three cases, I am going to roll down a marble. I need to observe where is the marble the fastest. Okay, in which case is the marble rolling down the fastest? It is the third case, because it is the smoothest when compared to the other two surfaces over here. What is the nature of these two surfaces? In the first case, the surface is pretty rough. That is why the ball is taking time to reach down. Okay, and it is experiencing lots of friction. Okay, with everyone. And what was with the cloth over here? It has certain folds. It is going to block the movement of the marble when it is rolling down. But what happens in the third case? The marble is easily able to roll down because there are no irregularities. There is no interlocking taking place between the marble and the glass surface, and it is able to roll down very easily. So what does this conclude? That smooth surfaces reduce friction, whereas the rough surfaces increase friction. Okay with everyone over here? So we have discussed the first factor over here, effect of roughness on the frictional force. The second factor over here is effect of area of contact on the frictional force. Okay, so now I have a setup over here. I am going to attach a spring balance to a brick. Fine, of certain weight. Now when I am pulling the brick with the help of the spring balance, I will note down the readings in the spring balance over here. What do these readings tell me? It is going to show me how much force is being used to pull the brick to a certain position. Okay, let it be F. Fine. Now in the second case over here, I am going to place the brick vertically, the same brick. Okay, when I place the brick vertically, I observe that the area of contact of the brick, this entire setup is definitely on a table. Of course, it is definitely not in the air. I hope you understand this. This entire setup is placed on a table. Okay, so when I place the brick vertically in the second case, I see that the area of contact of the brick and the table is less. Okay with everyone? In the first case, the area of contact of the brick with the table was much more because the brick was placed horizontally. In my second case, the brick is placed vertically. So now what am I going to do? I am going to try pulling the brick with the help of the spring balance, and again I am going to note down the force readings which are being displayed on the spring balance. I notice that both the force readings on the spring balance are the same. So what does this show? That the frictional force, okay, the frictional force is nothing but the limiting or the resisting force which is stopping the brick from moving further, is nothing but the same, and it is independent of area of contact. It doesn't matter if I place the brick vertically or if I place the brick horizontally or if I place the brick vertically. Okay, the amount of force used by me to pull the brick is always going to remain the same. This means frictional force is independent of this particular quantity over here. Okay with everyone? Now, in the third case over here, I need to understand effect of normal force on friction. If on this brick, this is brick number 1, I am placing one more brick over here, and that is brick number 2, and I am going to pull the brick now. What do you think the force is going to be? It is going to be twice the initial force that was used to pull for the first brick. Now when I've increased the load over here, the force is also increasing. Okay with everyone? Now when I increase the load over here, the normal force acting on this load is also going to increase. So what conclusion do we come to? We come to a conclusion that frictional force is directly proportional to normal force. So the more the load, the more is the normal force, the more is the force applied by you to pull it. Okay with everyone? And it is going to be more difficult for you to pull a heavier load. This means the frictional force is going to be more in this case because the load is much more heavier over here. It was a light load initially in the first case. In the next case, I'm increasing the load, so it becomes more heavier for me. Okay, in the first case itself, there was a certain amount of frictional force which was stopping the brick from moving further. Now when I've increased the load, and it is more tougher for me to pull the load right now. So what does this show? That frictional force is directly proportional to normal force. What is the normal force over here? The force acting vertically upwards on the bricks, because it is supported with the help of a table over here. It is acting against the solid surface, which is nothing but the table. So what conclusion do we come to? That the frictional force is directly proportional to normal force. So now class, we are on page number 25 and we need to understand a point. Is friction necessary? Is friction necessary? What do you think if there was no friction? You would be always flowing, you would be always moving and falling down. You would not be able to even build up buildings, because whenever you were trying to put up cement on the bricks, the cement would just flow down and not stop any time. Do you understand? So you need to think about it. Is friction necessary or not? How does friction help you? It helps you in driving your automobiles or vehicles. It helps you in writing. Yes or no? It helps you in walking properly, basically. The most first and the foremost thing. Try walking on a muddy and a slippery floor with flat shoes that doesn't have soles or grips. Okay, how do you think it is going to happen? Are you going to walk peacefully and without getting hurt or without falling down? No. As soon as you start or try walking on a muddy or a slippery floor, even though your shoes have good soles or good grip, you feel like as if you're going to fall down, because it is too slippery and you're not able to manage the balance, and you look for a support on the walls or on the sides. Do you understand? So now, how is friction helpful? We know this, like it helps us in walking, it helps us in driving our automobiles like bicycles, vehicles, and all that. And it helps us in writing. So basically, we also need to know how is friction not helpful to us. What are the disadvantages? What do you think can be the disadvantages? Now take the example of machinery. Okay, now, because the machinery parts in an automobile are always in contact with each other every time the engine is running, because of the contact and because of the frictional force between them, it causes overheating. And overheating causes the wear and tear in machinery parts. For example, the car has tires. Yes or no? You use the car for 2 years, and after some time, for few months, let's say 9 to 10 months, and after some time you see that the tires have gone worn out. Okay, why does this happen? Because you are regularly traveling in the same car every day from morning 10 to 5, and then you observe, because of regular usage of the cars, the tires have gone worn out. They have become smoothened. Okay, they don't look like as if they were brand new when you bought the car for the first time. Do you understand now? Why do you think has happened? Because of frictional force. Okay, now the frictional force between the tires and the road has caused overheating, because of which the tires have worn out and they have smoothened up. Okay, did you understand this part? The similar thing happens in machinery also. When you're using the same machinery for years and years without getting the servicing done, then it causes wear and tear of wires and the machinery parts inside the machinery, because frictional force between the machinery parts is going to lead to overheating. Okay, so what is the main disadvantage of frictional force over here? It causes overheating, and that leads to damage of machinery, basically. Now let's read further. Friction produces heat. Yes or no? I just told you. Now, when the machinery parts are in contact with each other and you switch on the engine and you turn on the engine and the car keeps driving, so this is going to produce frictional force, which is going to cause the heating. Okay. Now, for example, take your palms and rub them together. You can feel that it is producing a certain kind of warmth, a certain kind of heat. That is because your palms were in contact with each other. There was friction between your palms over here, which led to the heat. The similar thing happens in the machinery parts also. Try to compare the analogy over here. Like your palms were together and they were rubbed together, and that was causing heat between your palms. Similarly, the machinery parts are also in contact with each other every time the machine works. This is the reason overheating is caused, and that causes the machinery wires or the machinery parts to break up, and then it leads to faults and damages, and you have to replace either the machine or the machinery parts. Okay, now there was an example given in the textbook over here known as matchsticks. Now when I remove the matchstick and I strike it against the matchbox, there are certain chemicals present on the matchbox. When I strike the head of the matchstick on the side of the matchbox, that causes a certain amount of heat. Okay, now that heat is caused by frictional force between the head of the matchstick and the side of the matchbox. Try to understand what I'm telling you right now. Okay, so what example are we considering? We are considering the example of a matchbox over here. I open up the matchbox and I remove a matchstick and I try to strike the matchstick on the sides of the matchbox. What is in contact? It is the head of the matchstick in contact with the side of the matchbox. So when they are in contact, definitely they are experiencing what force? Frictional force. But when I strike it, what does frictional force lead to over here? It causes an increase in temperature between the head of the matchstick and the side of the matchbox. That increase in temperature causes the matchstick to light up. Did you understand over here? Okay. So what is the reason for the matchstick to light up? That is increase in temperature. And how did this increase in temperature happen? Because of the frictional force between the head of the matchstick and the side of the matchbox when they were strike together, when they were in contact with each other. Okay with everyone? Now, increasing or decreasing friction. How do you reduce friction? We just studied. If the surface is smooth, there is less frictional force. So this means if you want to reduce friction, you need to apply oil or grease or certain lubricants on the surface. Well, how does this help? If you are going to apply oil, lubricants or grease on the surfaces, the machine is going to move very easily. Do you understand? So this reduces the friction. The similar thing is used in vehicles also. You apply grease to whenever the servicing of your vehicle happens, try to observe it. They are going to apply grease in certain parts of your vehicle so that the vehicle is moving smoothly. Why do they apply such grease, oil and lubricants? Because it is going to reduce friction. It smoothens the surface of your machinery parts and that leads to reduction of friction. Now, how do you increase friction? We have discussed this example. If you consider your slippers, the sole of your slippers or the sole of your sports shoes, it has certain, grooves on it. Okay, it has certain grooves on it. Why do you think these grooves are present on the sole of your sports shoes? So that they give you the grip and you don't fall down while you're running. Do you understand? Now, this gives you the grip, the much needed grip required while you're running. Okay, this can be the sole of your sportswear or your slippers, and it has certain grooves and ridges on them. This grooves and ridges interlock with the rough surface on which you are running, and that helps you to run properly and have proper grip. That is the reason you are not able to fall down now. Okay, so the grooves on these soles of the sportswear is going to increase the friction. What is going to reduce friction? Oil, grease and lubricants. If you apply oil to your machinery parts or grease on any rough floor or lubricant on any rough floor, the machine that is moving or anything that is happening, even if you're rolling a ball on a rough surface, after applying a lubricant, the ball is going to move smoothly. Do you understand my point over here? If I take a rough surface over here, rough surface, and I apply a layer of lubricant over here. Okay, lubricant are nothing but all these oils which are used in vehicles. Okay, basically it is also a petroleum product. So now I'm going to apply a layer of lubricant over here and I'm going to roll a marble. The marble is going to move smoothly because of what? Because of the lubricant present on the rough surface. There is no interlocking happening between the marble and the rough surface now because it has been blocked by the lubricant over here. Did you understand now? So to reduce friction, you are going to use oil, grease and lubricants. To increase friction, the surface needs to be rough, or else the soles of a slipper needs to have grooves and ridges. Okay, let's come to the next part of the chapter over here. Effect of rollers on friction. Now, for example, take a suitcase filled with all your clothes. Okay, take a good heighted suitcase filled with all your clothes and you're trying to, and it doesn't have rollers. Okay, imagine that your suitcase doesn't have rollers and you're trying to push or pull the suitcase. The suitcase is filled. Remember that point. Are you able to do it conveniently? You're definitely going to face somewhat the other difficulty when you're pushing or pulling the suitcase which is filled up and which is very heavy. So what do you do now? You're going to put some rollers below the suitcase. You must have observed in advertisements and all, like sky bags. there are rollers, and there is a handle also for support so that you can pull the suitcase in a certain direction. So in the second case, my suitcase is having rollers now, and I'm trying to pull the suitcase which is still having all my clothes. Am I able to pull the suitcase in the second case? Yes. Why was I not able to pull the suitcase in the first case? Because it was heavy and it required more force, and there was more frictional force present, and I was not able to slide it. But as soon as I put some rollers and I fix some rollers in my suitcase, I'm able to pull the suitcase very easily. You must have seen on airports and stations and all, like people are using roller suitcases and walking along with their luggages. It is very easy to pull them. Why do you think it is easy to pull them? Because of the rollers. The rollers are able to balance out the weight of the suitcase, and also the friction present between the rollers and the floor on which the suitcase is moving is called as the rolling friction. What is it called? Rolling friction. This is the third kind of frictional force that you are studying. What were the earlier two? It was sliding friction and it was static friction. Okay, which is the best friction as of now? What do you think? It is the rolling friction. It requires very less amount of strength to carry an object if it has rollers on it. Do you understand? For example, there is a box placed on a table. Okay, there is a box placed on a table, and I'm trying to push the box. Fine. If I'm trying to push the box and it is really heavy, I might take lots of force to push the box. So if I fix some rollers underneath the box, or if I place some pencils, you know how do pencils look like? Yes, you know how is the surface. If I place 4 pencils underneath my box, and now if I try to push them along with the pencils, don't you think the movement of my box is going to be easier in the second case because of the pencils? The pencils are going to act as what? Rollers, basically pencil rollers. Now do you understand how is rolling friction helpful to you? Okay with everyone now. Now, understanding the principle of ball bearings. The same principle of pencil rollers can be used for ball bearings also. If I take two lids, okay, something like this. If I take two lids which are of equal size and weight, and I'm placing them in contact with each other, and I'm trying to roll them on each other. Okay, I'm trying to move them on each other. Because they are very heavy, it becomes very difficult for me. So what do? I place some balls between them. Fine. What do? I take the first lid. I'm going to place some balls over here, and the second lid is placed down. Now after I have placed few balls between the two lids over here, I try to move the lids. Can you notice some difference in the second case over here? It becomes easier. Yes or no? In which case is it easier? Without the balls or with the balls? Definitely with the balls, moving the lids has become really easy. Okay, now this is called as the principle of ball bearings. The same principle is used in very heavy machinery to move different parts. Okay, now they are going to place some ball like instruments or metal balls between two machinery which have to be in contact with each other, and once the machine is turned on, the lids start moving easily because of the metal balls present between them. What is this principle called as? Principle of ball bearings. What did I do earlier? I was having two metal lids which are very heavy in weight, and I was trying to move them on each other. I was finding it very difficult. So what did I do? I placed some balls between them, and now I try to move it. So because of the shape of the balls, it is very easy for me to move the metal lids over each other. So what is this principle called as? It is called as principle of ball bearings. And where is this principle of ball bearing used? In heavy machinery. Whenever the parts of heavy machinery need to be in contact with each other, they are going to be fixed in such a way so that there are metal balls present between them, depending on the size of the machinery parts. Okay, if there are big machinery parts, then definitely the metal balls are also going to be huge and more in number, and they are going to be placed along the circumference of the machinery part. Do you understand? So this makes my work easier. Okay, so why are we using rollers over here, or why are we using metal balls? So that the movement of the lids become easy. So which friction are they possessing over here, or which friction are they showing? It's rolling friction. Fine. The last and not the least is observing fluid friction. Okay, you will learn in class 9. Okay, so you will learn in class 9 that in chapter number 1 it is specified that fluids are nothing but liquids and gases. Anything that is flowing is called as fluids. So under the fluid terminology comes both liquids and gases. So we need to observe fluid friction. For this you're going to take a glass filled up with water and you're going to stir it with a spoon. Can you see the water whirling? Okay, now take the example of your washing machine also, which is front load. Okay, once you switch on the washing machine and the washing machine is filled up with water, you can see your clothes moving in the water in the machine over there. They are whirling. Okay, so what was the example I was discussing? I have a glass filled up with water and I am stirring it. While I'm stirring it, I can observe that the water is whirling inside the glass. Okay, after some time it stops because I have stopped stirring. Okay, why does the water stop now? And why does it whirl? It is all because of a friction present in the liquid over there called as fluid friction. Now what does the fluid friction depend on the glass of water over here? It depends upon the water, it depends upon the liquid layers, it also depends upon the liquid layer and the layers between the water and the glass surface over here. Okay, because the water is contained in a glass, you have filled up the glass with water and you're stirring it. So once you're stirring it, it keeps moving, and once you stop stirring, it moves for a while. Okay, it whirls for a while and it stops. Do you understand? It does not keep whirling all the time and forever. Okay with everyone? So what were we talking about? We were talking about fluid friction. I've told you fluid is nothing but gases and liquids. Okay, so now I have a glass of water over here and I've told this again, I'm repeating it. If I stir the water with the help of a spoon, it is going to whirl for a while and it is going to stop after some time. It is all because of fluid friction. Now what does the fluid friction in this case depend upon? It depends upon the liquid layers as well as the contact of the liquid layers with the glass. Okay, it is going to depend upon these two factors in this. Now for example, if you take a tub filled with water and you try to move the water inside the tub with the help of your hand, on which, okay, you are dipping your hand perpendicularly inside the tub of water and you're trying to move the water inside the tub. So where are you going to face more amount of friction? You're going to face more amount of friction on the open end over here, okay, while you are moving it. The frictional force experienced by fluids has a certain terminology called as drag. Okay, the frictional force experienced by the fluids is called as drag. So now the example that I gave you over here, moving your hand inside the tub of water and where you are facing more amount of friction, the friction faced by the hand inside the water while you're moving it in a certain orientation is nothing but fluid friction. Now for example, if you have a boat, okay, and you have left it in the lake, so you have not anchored it to a certain point. You forgot anchoring it with the help of a rope and an anchor, and you just left the boat in the lake. What do you see? That the boat starts flowing. Okay, this means there is a certain friction which is enabling the object to move in the reverse direction. Do you understand? That is what is frictional force. Yes or no? It enables the object to move in the reverse direction. Remember the toy trolley and the block? Once the weight was increased because on the trolley, the block started falling in the reverse direction. What is this reverse direction movement called as? Deceleration. That is why the boat also starts moving along with the water because of the fluid friction. Now, fluids like the air and water, there are animals present in them like the birds and fishes. So what do you think they do to overcome the friction present in the gases and liquids? They have definite shapes, they are evolved that way. Nature has evolved the birds and the fishes in such a shape that they're able to overcome the friction which is present in the respective fluid. For example, if there was no friction, okay, if there was no proper shape of the bird, do you think the bird would be able to land safely on the ground? Okay, it would always be blocked by the friction present in the air. Okay, so you should understand that the shape or the body of the object or the bird over here helps it in landing and moving in the air. The similar thing happens with the fishes also. They have a certain structure, they have a certain shape which helps them in moving inside the liquid. What is the liquid over here? The sea water or the ocean water? Now you have understood that all the liquids and gases have friction. Okay, all the fluids that we are going to talk about definitely have friction, but the aquatic or the aviar animals which are moving inside these fluids, they need to overcome the friction in a certain way. Do they do something? No, they definitely have a certain body shape. Okay, they have a certain body shape which helps them to overcome the friction, which helps them in flying, which helps them in landing or reaching a certain place. The similar thing happens with the, fishes also. Now, by looking at this, people were inspired and they made something called as aeroplanes and submarines. Do you understand? Now, if you compare the shape of the aeroplane with the bird over here, you will understand that it actually looks like a bird. Okay, that is the reason that the aeroplanes, when they're landing, they're able to apply proper brakes, and they're also able to move in air because the birds are also moving. They have a definite shape, they're able to overcome certain amount of friction to a certain limit. The similar thing happens with the submarine also. If the submarine is dipped inside water, or it is moving inside deep underwater, you when you observe the shape of the submarine, it looks like a big whale. Yes or no? Now, if the whale is able to move inside the fluid called as water or the oceanic water or the sea water, the submarine is also able to move. Why is it happening? How are these objects or animals or birds able to overcome the fluid friction? What is the reason behind this? Because of the shape. So what are the factors which are going to affect fluid friction over here? It is definitely the speed of the fluid. Okay, if I keep stirring the glass of water with lots of force, it is going to stir and stir, and it is once I stop stirring, the whirling is going to stop after some time because of the speed that I've applied while mixing the water in the glass. If I was doing it with less pressure and less force, with a very light amount of force, then the whirling of the water will stop sooner. Did you understand? I am explaining what factors is fluid friction dependent upon. The first factor is the speed of the fluid. What did I say you? If I keep stirring the water continuously and very fast, and I stop stirring, after the whirling of the water is going to stop after some time because of the force applied by me. Okay, that was directly proportional to the speed which caused more whirling inside the fluid. In the second case, if I do it with very less amount of force and do it leisurely and very slowly, how is the whirling going to stop? It is going to stop very soon. So what factor does the fluid friction depend upon? It depends upon the speed of the fluid. It also depends on the shape of the object. How does it depend on the shape of the object? All the automobiles are designed in such a way that it is able to overcome friction to a certain level. If there was no, the shape of the object was not taken into consideration, none of your automobiles would be able to apply brakes. No plane would be able to land or take off. Did you understand? These all are inspired by the shape of the objects. Now, what is the last and the but not the least factor over here? Nature of the fluid. If instead of water I was using oil, the fluid friction would be something different. If instead of oil I was using petrol, then again the fluid friction would be different because the density is different over here. The viscosity of oil and petrol with respect to the glass is going to be different. Similarly, what about gases? The birds are moving in air, yes or no? If the birds were moving in some other kind of gas, like, you can't do that, of course they need oxygen to breathe, but this is just an example. Okay, if they were moving in a different denser gas like chlorine or bromine, then it would be difficult for them to move. It would be difficult for them to overcome the friction that the gas is actually putting on them. Okay with everyone? So here, as I told you, frictional force increases with the normal force. So more the weight of the gas, more is the friction. Air is a very light gas. That is why, it has a certain amount of friction. It is a composition of too many gases. But yes, definitely the birds are able to overcome it. That is why you see them flying. And similarly, in the oceanic and the sea water also, the fishes and the whales and the other aquatic animals are able to overcome the fluid friction in the sea water or oceanic water because of the shape of the object and also the nature of the fluid. It will be different if the liquid is mixed up with some other chemical or some other substances. Then the friction varies in ranges. Okay with everyone? So that's the end of the chapter. We have learned about four kinds of friction: sliding friction, static friction, rolling friction, and fluid friction. We have learned what factors are they dependent upon, what increases and decreases friction, and we have also learned about very simple activities. In the next class, we will discuss the think and discuss and the MCQs. Thank you. Please read. So yeah, we have Sakshi over here. Please note it down. We have completed chapter 2, which was a very small chapter, and then the chapter is explained. I want you to go through line by line and read it properly. You have ample of time. Please do it. Reading doesn't take away your time, it only builds your knowledge. I want you to read the chapter thoroughly. Only if you read the chapter in science, whether it is physics or biology, only then you're able to understand what is happening inside the chapter, what is there, what is the content in mentioned in the chapter. Go through the word by word, underline that you have understood and you find it is important, underline what was mentioned in the class. Also underline and highlight what you have not understood also, so that you can delve deeper about it. Okay, curiosity only helps you to build your knowledge. Please note down, Sakshi. Thank you.